So today we are gonna learn about green cloud computing. So my name is Aabhas Garg. So first, the reason I have called it as e-journey is because we will come full cycle at the end of this presentation. So basically, e-journey includes basics of green and cloud computing, green cloud computing, a data center perspective, green cloud computing in developing regions, balancing energy in data centers, energy aware data center management, power usage effectiveness, case studies, Senegal and South Africa, Indian scenario, go green, references. So the definition of green cloud computing as given by Sam Erickson, the Organization for Economic Cooperation and Development has published a survey over 90 government initiatives on green ICTs, information and communication technologies, the environmental and climate change. The report concludes that initiatives tend to concentrate on the greening ICTs themselves rather than on their actual implementation to tackle global warming and environmental degradation. So, green cloud computing. When talking about a cloud computing system, it is helpful to divide it into two sections, the front end and the back end. They connect to each other through a network, usually the internet. The front end is the side computer user or client sees. The backend is the cloud section of the computer system. So as you can see, there is a virtualized computing platform, scalable use of computing resources, pay-per use concept, passive consumers to pro consumers, Amazon, Google, Microsoft, service levels, platform, software. So, so transition form, cloud-based expenditure, CAPEX to operational-based expenditure, OPEX. Okay. So the party provider access via the internet, usage-based economics, capex to opex, low IT skill to implement, etc. Steps mentioned here are according to IBM's Big Green approach to data center energy efficiency. Virtualization continues to be one of the hottest green data center topics. Many current server CPUs utilization rates typically are over between 5 and 15%. So direct data storage utilization sits between 20 and 40%, with network usage between 60% and 80%. Virtualization can increase hardware utilization by 5 to 20 times and allow organizations to reduce the power of consuming servers. Cloud computing is the ultimate virtualization. So supply chain energy usage, green data centers, diagnose opportunities and problems, measure and manage, cool banking panel, virtualize, build, server utilization, energy aware consolidation are some of the steps. Moving processing and data closure to the user in developing region plays an important role on three fronts. Keeps needed jobs and systems, ICT people in the region, sidestep high telecommunication bandwidth, cost, and network latency issues in and out of the region, and quality of service. In a region, computing can remove a major point of network failure and potential bandwidth bottlenecks. PPP, public-private partnerships. So, Germany example serves as an excellent example as the country has become the world leader in solar power, with half of its world installations within its borders, thanks to policies and aggressive renewable energy slides and large sums of money devoted to research. So the power consumption data for each and every servers was obtained by first calculating the maximum power using HP power calculator, then following the convention that average power usage for mid-range high-end servers is 66% of the maximum power. Hard disk arrays include supporting functionality such as cache memories, disk array controllers, disk enclosures, and redundant power supplies. In a cloud computing data center, all the storage spaces in the data center is consolidated and hard disk usage is centrally coordinated. So through server virtualization consolidation, a very large number of users can share a single server, which increases utilization and in turn reduces the total number of servers required. Users do not have to have a need of any knowledge of the task being performed by other users and utilize the server as though they are the only user on the server during periods of low demand. Some of the servers enter sleep mode, which reduces energy consumption. So OLPC, one laptop per child project examples such as $100 laptop in US or Akash tablet PC launched in India. These signify the innovations under adverse conditions. The first technological innovation highlighted herein focuses on the visibility on small cloud computing farms deployed in small scale data centers using low processors like Intel Atom, ARM Cortex, and Via Nano. The central processing units, originally designed for use in notebooks, require only 2 to 10 watts versus 80 to 160 watts for the processors typically used in data center servers. These low-power processors also have the quiescent state that consume little energy, unlike the standard data center CPU that consumes 50% of its peak energy even while in the ideal mode. So Microsoft Research has an organizational division called Cloud Computing Futures focused on reducing the operational cost of data centers and increasing their adaptability and resilience to failure. Among their findings, these processors offer substantial fractions, 30 to 50% of the performance of the high-performance processors used in Microsoft data centers, but consume a disproportionately smaller amount of power, 5 to 10%. Comparable studies have been performed, obtaining similar results at Cami Mellon's University. So found FAWN, a fast array of wimpy nodes. The Green Scale Center of Energy Efficient Computing at the University at Santa Barbara. So prioritization, if we prioritize energy saving instead of operate on a smaller, more cost-effective solar PV system using energy-aware cloud computing, it will allow us also to manage the cloud computing load during extreme weather conditions by shutting off non-essential activities. This leads to energy-aware cloud computing. The Green Grid Consortium estimates that even in a efficient data center, 42% of the global total power delivered to traditional data center is consumed by chiller, cooling, and computer room air conditioners. One innovative approach is twofold, eliminating the majority of the heat to allow the use of ambient cooling, augmented with rack cooling, and running the data centers at higher temperatures. The use of ambient cooling can be tracked back for centuries in Middle East and across Africa, as people from these regions now consider a part of developing world harness the cooler temperatures found underground to provide cooler air to vent above ground built structures, as in thermal chimney. Same can be applied to data centers. So PUE definition, power, overall power drawn by the facility divided by the power delivered to the data center. PUE relates the total consumption of the installation with what considered essential to the service, the computer servers, IT load. It is the responsibility of the IT manager to reduce the consumption of IT load, renewing servers, virtualizing, etc., and the responsibility of infrastructure managed to reduce the auxiliary consumption, the more efficient equipment, free cooling, etc. Carbon usage effectiveness. CU defines CO2 emissions associated with DC losses. So energy use dashboards and Montpellier, France. The demo center in Montpellier, France is called PSSC, Product and Solutions Support Center, Green Data. Center of the future. The main idea was to create a customer friendly real time and green showcase production data center that will demonstrate a large percentage of the currently available best practices in IT and facility energy conservation, integrating at least one bleeding edge major conservation technology. The information on the use of live camera, thermal camera, and green IT energy use real-time dashboards available to IT personnel through a portal are interesting. Innovations that can help communicate the energy efficiency of the data center to the interested employees. The power usage effectiveness is the metric used to measure the energy efficiency of a data center. Both IT and non-IT resources energy conservations are gathered. The two PUEs are measured overall and high density zone. So workload diversification, because many different sorts of users will be availing themselves of diverse cloud resources, different application, different feature set preferences, and different usage volumes that will improve hardware utilization and therefore make better use of power that is being used anyway to keep server up and running. Power management, flexibility. It's easier to manage virtual servers than physical servers from a power perspective. If hardware fails, the load can automatically be deployed elsewhere. Likewise, in theory, all virtual loads can be moved to certain servers when loads are light and power down or idle to those that are not being used. Recent implementation of cloud computing. Virtualization at a Canadian non-profit, Earth Rangers, demonstrated their ability to replace 4 rack of servers with half rack of servers and half of their storage for the entire IT operation. So this is the case study of is of a large cell phone company in South Africa. The cell phone company was experiencing very typical concerns for large companies with their test and development environments. There was a significant amount of test server waste due to the lack of governance and management. For example, every project gets servers for testing, and the servers were often not released when testing is completed. A private cloud was proposed to manage countries' virtualized test environments. The private cloud was designed to provide tight governance, automated provisioning, and decommissioning of environments allocated to projects. So there are 1100 plus server instances. The number of instances has grown exponentially over the past 5 years. The case study for a bank in Johannesburg, South Africa provided much of the incentive of cell phone company described above. So the benefits is speed. The test system setup that previously took 2 weeks now took only 2 hours. Energy saving, the bank reported a reduction of virtual servers by half, reducing power and cooling in half. Conclusions. Incentive for IT hardware and software makers to have better management or measurement facilities. So this is the Indian scenario, as you can see. So these are some of the facets of research concerning the Indian scenario. IPTV, IP television, VoIP, voice over internet protocol. So now these are some refer conclusions and future scope. Go green examples mentioned will help in harnessing energy. Lots of research to be carried out, maximizing efficiency of great data centers, developing regions to benefit the most. Thank you.